Hi everyone, welcome back, and we are going to solve some word problems. There are many ways questions can be asked, so let's look at the first example. In example 13, by first principles thinking, we first identify that this is a linear inequality question which will require us to find the values of x from the given relation and subsequently identify the various types of values of x. So, let's solve the inequality by first opening up the terms in the brackets and simplifying both sides of the inequality. This is step 2 of first principles thinking, where we identify the techniques and properties required of the question. But really, it should be instinctive for this question. I guess it is obvious at this point that we employ property 4b and divide both sides by -2. Remember to also switch the signs, and you'll get x smaller or equals to 85/2 or 42.5. Step 3 of first principles thinking is where we formulate an approach. For questions like this, the approach is straightforward and does not require much formulation. Part A asks for the greatest rational value of x. A quick recap of what rational number is: it is simply a number made by dividing two integers. In this case, the answer will be x equals to 85/2 or 42.5. In part B, the question asks for the greatest integer value of x. An integer is essentially the range of positive and negative whole numbers. In this case, x will be equals to 42. The question asks for the greatest prime number x in part C. A prime number is any number that can be divided by 1 and itself. Note that 1 is not a prime number. Hence, the largest prime number in this case is x equals to 41. It is not hard to identify or define the problem in example 14. The question is rather straightforward in what it requires. Let's talk about step 2 of first principles thinking. For part A, we know that to get the greatest value of a difference of two numbers, we need to ensure the first number is at its greatest possible value, and the second number, the one being subtracted, is at its lowest value. We need to be aware of the squares, power 2, as we deal with the negative numbers. In this case, for step 3 of first principles thinking, we will choose x to be 5 as it is the greatest value, and y to be 0. For y, choosing any other number would make it a squared value larger than 0, making 0 the obvious choice. Hence, the greatest possible value of x squared minus y squared will be equals to 5 squared minus 0 squared, and that will give you 25. In algebraic fractions, for positive y and x, the smaller the denominator and the larger the numerator, the larger the value of the fraction. Hence, in part B, we will choose the largest positive value of y, which is 2, and the smallest positive value of x, which is 1. That will give us 2 as the answer. Part C is slightly more tricky than the others. What is chosen as the numerator needs to be the same as the denominator. The idea is still the same as part B, just that we are looking at the least value, hence the larger the denominator and the smaller the numerator, the smaller the value of the fraction. Since we want the least value, the value of x must be as small as possible such that the 2x term in the numerator is not contributing too much of a difference from the x term in the denominator. Substituting x equals to 1, the 2x term will be 2 and the x term in the denominator will be 1, giving a difference of 1. Compared to using x equals to 4, where 2x is equals to 8 and x in the numerator is 4, the difference will be 4. So, x equals to 1 is the obvious choice. We will also choose the largest y value to contribute to the largest possible denominator. In this case, y equals to 2. Substituting the values, we will get 4/3 or 1 1/3. In part D, we will find the possible values of x by square rooting both sides of the equation, giving us x equals to plus minus 4. We will reject x equals to negative 4 as this is not within the defined range of x in the question, which is x between 1 and 5. So, the answer for part D is x equals to 4. In example 15, let's define the problem by means of visualization and diagram. It is given that the length of the plot of land is 3x plus 2 and the width is 2x. The perimeter of a rectangle is 2 times length plus 2 times width. Hence, in this case, we can write the perimeter P as P equals to 2 times 3x plus 2 in brackets plus 2 times 2x. It is also mentioned that this perimeter is at least 64 meters but less than 90 meters. If you recall, at least means greater or equals to. So, P is greater or equals to 64 and P is less than 90 meters. So, this. Combining the two inequalities, we get the following simultaneous inequality. We can go on to simplify the inequality at this point. Now, we have fully defined the problem and identified the methodology and technique that is required, which is solving simultaneous inequalities. We will proceed to solve this question. Using what we learned in the previous segment, we will use the first two expressions as the first pair of inequalities. Bringing the values to the left, we will get this. Using property 4a, we divide both sides of the inequality by 10, giving us x greater or equals to 6. We can then do the same for the second pair. You can choose to draw a number line, but in this case, it may be obvious that the range is this. In example 16, Madeline has $50 and she wants to buy some paper files and plastic files. Each paper file costs 45 cents and each plastic file costs 85 cents. She needs to buy at least 10 of each file, so what is the maximum number of files she can buy? This question requires the use of certain amount of general logic. At first glance, we may not be able to see that this is an inequalities question. Hence, you have to rely on your deduction to peel away the layers. Firstly, let's try to define the problem. The maximum number of files that Madeline can buy with $50 is where the denominator is the smallest. The denominator in this case is a combination of the cost of paper files and plastic files, with plastic files costing more. Hence, to maximize the number of files bought, we should minimize buying the more expensive files and maximize buying the cheaper files. However, there is a criteria where a minimum of 10 of each files needs to be bought. So, putting our findings together, it is easy to conclude that we should buy 10 plastic files at most, since they are the most expensive out of the two, and a minimum of 10 files is required to be bought, giving us 10 times 85 cents. The remaining amount will be used to purchase as many paper files as possible. Let that unknown quantity be x. That means the total cost is x times 45 cents for paper files. The total cost of paper and plastic files cannot exceed $50. Hence, the inequalities can be written as this. This is then seen as solving a linear inequality, and we can employ the basic properties to do so, giving us x smaller or equals to 92 and 2 over 9. This means that the maximum number of paper files she can buy is 92. With that, the maximum number of files she can buy is 92 plus 10, which is equals to 102. We have attempted 4 different kinds of word problems, but there are many more kinds. You should practice as much as possible at your own pace and try to make use of the first principles thinking methodology to approach your word problems. You will find it useful for even more complex questions. For now, let's tie this chapter up in a pretty knot, shall we? I'll see you in the next video.